Hello students, this is the continuation of the worksheet 1.1 and here mainly I have taken the numericals on Coulomb's law and the theory class we have discussed already what is the Coulomb's law. So the Coulomb's law states that if there is two charges placed Q1 and Q2, so always there is an electrostatic force between them. So if the distance between them is, let us take that as r, that the force, electrostatic force, the between them is directly proportional to product of the magnitude of two charges, and that force is inversely proportional to 1 by inverse proportional to r square. It obeys the square inverse square law, and if we take that, you will write that is equal to k into q1 q2 divided by r square. This k is proportionality constant. So that proportionality constant is 1 by 4 pi epsilon naught. So where epsilon naught is the permittivity of free space. So this very important because these two charges are placed in a vacuum now. When it is placed in a vacuum, this is epsilon naught. If you place in some other medium, so this value goes on changing. Suppose if you are not placing in a vacuum, if you place it in a water, so this epsilon naught, we cannot write it as epsilon naught. So the water will have a different permittivity. So this varies from medium to medium. And this 1 by 4 pi epsilon naught, we have a constant that is 9 into 10 to the power of 9. Right, this is the value of this 1 by 4 pi epsilon naught. So now, having understood this, so this is enough for us to solve this video problems. Okay, so let us take the first problem. The electrostatic force of repulsion between two positively charged ions carrying equal charges is 3.7 into 10 to the power minus 7 Newton when they are separated by a distance of 5 angstrom. How many electrons are missing from each ion? So suppose this the question is given like this. So the two charges are placed, two positive charges are placed. So plus Q1 and plus Q2, and they are separated with a distance of 5 angstrom. Distance is 5 angstrom, that is R is equal to 5 angstrom. And the force between them is also given, that is F is equal to 3.7 into 10 to the power of minus 7 Newton. That is also given. Now, R is 5 angstrom, that means, so angstrom you know it, angstrom is 10 to the power of minus 10. So 5 into 10 to the power of minus 10 meter. Now, and they also given that Q1 is equal to Q2. So that is equal to Q. Let us say that Q1 and Q2 will be equal to Q. Okay. Now we know the Coulomb's law. Here I have already written F is equal to K into Q1 Q2 by R square. So use the formula. So the formula which we are using according to Coulomb's law. So F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. So that is equal to 1 by 4 pi epsilon. We know that Q1 is equal to Q2. So I can write that as Q square by R square. Now we need to find out what is this Q, because we don't know Q. What is the magnitude of this Q? Then if you find out, then we can also find out how many electrons are missing from each ion. This are Q1 and Q2 are positive ions. Now we know F value. So substitute F value. So 5 into 10 to the power of minus 10 meter. I'm sorry. That is 3.7 into 10 to the power of minus 7 Newton. So that is equal to, this value, that is 9 into 10 to the power of 9 and Q square, and R is 5 into 10 to the power of minus 10 so square. So if you solve this implies that you get that as Q square, you'll get it as 10.28 into 10 to the power of minus 38 Coulomb. Coulomb square, you will get it. So Q will be equal to square root of this. So the square root of this is 3.2 into 10 to the power of minus 19 Coulomb. So this much of the charge each one is having. So we need to find out how many electrons are missing. Means if this has to become positive. See, if you keep the charge, if you keep any object as it is, that charge is zero. It doesn't have any charge. If you rub or if you do some charging methods, induction or rubbing method, so this gets charged. So this gets charged means if this is becoming positive, meaning is it is losing some electrons. Now we got to know that this each one is having a charge of 3.2 into 10 to the power of minus 19 Coulomb. That means to get this much of charge, they might have lost something. They have lost electrons. How many of electrons are losing from them? So you can get it that. So here I write number of electrons are missing. Electrons missing from each ion. So that is very simple. We already discussed in the previous section. Q is equal to Ne. So we have to find out N. That's it. I know the Q. So Q by E, if you do it, so you will get Q by E is how much? Q is 3.2 into 10 to the power of minus 19. So E is 1.6 into 10 to the power of minus 19. So this goes 3.2 divided by 1.6. That is nothing but 2. So 2 electrons are missing from each atom. So 2 electrons are missing from each atom. Missing from each atom. Alright. So this is the thing. That means if they miss the if they're losing the electron, that means they're getting positive. If they gain the electron, they become negative. Right? That is the thing. So since they are positive ion, so they're losing the electrons. Now, second problem. So the second problem has taken such a way. This is from your NCRT textbook. So this problem is very very important to compare the electrostatic force and the gravitational force. So they both obey the inverse square law. So both are inverse proportional to r square. So let us see what is the thing here. Two insulated charged copper spheres A and B are have their centers separated by a distance of 50 centimeter. What is the mutual force of electrostatic repulsion if the charge on each is 6.5 into 10 to the power minus 7 Coulomb? The radii of A and B are negligible compared to the distance of separation. Also compare this force with their mutual gravitational force. That means first we need to find out what is the electrostatic force between them. Then we should compare with the gravitational force. Very simple it is. So the given is there are two spheres A and B. So they are separated with a distance. They have given that distance is r is equal to 0.5 meter. So 50 centimeter, so 0.5 meter. And each one is having the charge as the given as 6.5 into 10 to the power minus 7. So that is this is Q1 will be equal to 6.5 into 10 to the power minus 7 Coulomb. So that is also equal to Q2. Q2 is also same. So that is a given thing. So easily find out electrostatic force, that is Fe. We can find out. So I'm naming it as Fe because it is electrostatic force. So K into Q1 Q2 divided by r square. So simple, very simple it is. So you can find out 9 into 10 to the power of 9. So 1 by 4 pi epsilon naught, this K value. Then substitute 6.5 into 10 to the power of minus 7. So whole square. So divided by. So r is 0.5 square. So you will get this as 1.5 into 10 to the power of minus 2 Newton. I am not concentrating on the calculation part of it. So you need to do that. Now find out what is the gravitational attraction between them. So because our gravitational force is always attractive force. So the mutual gravitational attractive force. Mutual gravitation mutual gravitational attractive force. So that is given. So uh, Fg will be, we know the formula, the gravitational constant, universal gravitational constant, m1 m2 divided by r square. So they have given the mass also, mass of each, so which weighs 0.5 kg. So each sphere weighs 0.5 kg. So substitute the things and you will get the value. uh, G value is 6.67 into 10 to the power of minus 11 into mass is 0.5 kg, 0.5 kg divided by separation is 0.5 whole square. So this goes with this. So you will get that as 6.67 into 10 to the power of minus. So we get this as 10 to the power of minus 11 Newton. Observe this and this value. So it clearly says that, so Fe is very, very greater than Fg. So that's why the universal forces, gravitational force, electrostatic force, weak nuclear force, strong nuclear force, are based on this. So I didn't change the distance between them or things, but always the electrostatic force will be greater than gravitational force. Now, it is very clear. So from this example, it is very clear that electrostatic force is greater than gravitational force. Now let us take the second one. What is the force of repulsion if each sphere is charged double the above amount and the distance between them is halved? Very simple. So it's like taking like the this is the first part. The second part is here. So Q1 is equal to 2Q and Q2 is also becomes 2Q. So because we are doubling the charge. Now let us say, let me call F dash E now. So that is K into, now Q become 2Q1 into 2Q2 divided by, the R is also reduced. So now R dash new one will be R by 2. So that is R by 2 whole square. So distance is simple. You take an example here. So sphere A and sphere B. So sphere A distance was earlier R, that is 0.5 meter. So now it becomes 0.25 meter. That's all. And this charge becomes doubles. Now if you calculate that, substituting the k value, simple, don't go on substituting the k value, q1 value, q2 value, r value, don't substitute. So make it simple. So if I take this becomes r by r square by 4. So if I take out upside, that becomes 4, and this 4 into 4, so this 2 into 2 4, so 4 4s are 16 it becomes. So into k q1 q2 divided by r square. This value you already know it from the book. Look at here, this is the same as, this is same, k q1 q2 divided by r square. So we already got the value. So this is 16 into 1.5 into 10 to the power of minus 2 Newton. So if you calculate that, so you will get the value as 0.24 Newton. Okay, so that means the force is increased now. So earlier it was only 1.5 into 10 to the power minus 2, so now it's 0.24 Newton. Okay, the next one, this is a famous problem. So it's also given in your NCRT book so many times. It's appeared in your exam. Let's take, suppose two spheres, same, the it's continuation of the above problem. But we have a two spheres here. Little change. The two spheres A and B. The third sphere of the same size but uncharged. These two are now charged. They have a charge already. Is given that charge is 6.5 10 minus Coulomb is given there. But we are bringing one more charge, that is C, so which is uncharged, is brought in contact with first A and then brought with the contact with B and finally removed from the both, so that C will remove, and what is the new force of repulsion between the A and B? Now we have to find out what is the new force of repulsion between A and B. So look at here, the first case, let's say I have a sphere A here, so which is having a charge Q, and I am bringing the uncharged C, that is the charge on this is 0 now, it doesn't have any charge. And if I bring and touch it, both of them, if you brought in contact with the A, so what happens is the charge will redistribute. The A is having Q, now it is redistribute. So A will become Q by 2 and C also becomes Q by 2. That means this charge is going to redistribute among both the bodies. Now I have B now. B is having Q. Now C is having charge Q by 2 because I already made contact with A and I am bringing near to the B. So now the total charge of the system is how much? It is Q plus Q by 2. So that means it is already having the charge of, you can find out. So if we take the LCM 2, so 2q plus this is 3q by 2. The total charge of the system is already 3q by 2. Now if I made them in contact, if I bring them in contact, now this will become redistributed. So that means each one will have now will have charge as, so 1 by 2 of 3q by 2. So that will become 3q by 4. So that means B will have a 3q by 4 and C will also have a 3q by 4. So now the new charges on A and B. So A will have a charge that is q by 2. B will have a charge 3q by 4. Now find out the force of attraction. So the distance between them is same. No, it's not changed. That is 0.5 from the above problem. It is same. Now if you find out the new repulsive force, so that is F is equal to, so K into the Q is now, one is 3q by 4, one is q by 2, so distance is r square. So just say do the calculation, so it becomes 3 into 3 by 8 because 4 2s are 8, so upside is 3 is there, then remaining is k into q1 q2 divided by r square. This value you already know from the above problem, that is 1 point, so look at here, this is 1.5 into 10 to the power of minus 2. So 3 by 2 into 1.5 into 10 to the power of minus 2 Newton. So that will give you the value of 5.7 into 10 to the power of minus 3 Newton. So that's the way. So here we need to understand very important thing, this process what we did here. After that, it is only just a calculation using the Coulomb's law. So here, if you bring uncharged body near a charged body, the charge will redistribute in such a way that both will have a same charge. So here, the Q was having 0, but A was having Q. So when I made in contact, so A got Q by 2, C also got Q by 2. Similarly, here I brought Q and Q by 2. The total charge of this was the system. Now it is 3Q by 2. Now when they made them in contact, so each one will get a half of this. Half of 3Q by 2 is 3Q by 4. Alright. So then you find out the force between them. Okay.